So it's not a perfect circle, but it's got a radius r. Now, if I know the radius of the circle, can I calculate the circumference of the circle? Okay, the answer should be a resounding yes. You can. The circumference is just equals to 2 times pi times the radius r. That's just the circumference of the circle. So if the radius is in meters, 2 pi times that gives me how many meters the circumference of the circle is. So would you agree with me that the ratio, the circumference over the radius, is equals to 2 pi? Okay, now this is quite interesting because on this side we've got a number. Pi is just a number. It's a very weird number in that it's a decimal and it's got all these numbers that never repeat after it, but still it's a number, it's non-changing. So we've said that the circumference of a circle divided by its radius is equals to a number. And that must hold for all circles. So for any circle, no matter how big it is, if I take its circumference and I divide it by the radius, I must get exactly 2 times pi. Right? So if I am only interested in a half circle, right, so for a half circle, I've got half the circumference divided by r, and this will be equals to just pi if I divide by a half on both sides. For a quarter circle, I get a quarter of the circumference divided by r is equals to pi over 2. So a full rotation, the arc length of a complete circle, if I divide by the radius, I get the number 2 pi. The arc length of a half circle divided by the radius gives me pi. The arc length of a quarter of a circle divided by r gives me pi over 2. And these numbers now give me an alternative way to describe angles. This is equivalent to basically 360 degrees. So full circumference or full rotation, we know is described by 360 degrees, but by just using the formula for the circumference of the circle, we can also say, well, we can relate a full rotation to the number 2 pi. For a half circle, this must be equivalent to 180 degrees. So we know if I've got half a circle, the angle that subtends that half circle is 180 degrees. Or we can say, well, that arc is somehow described by the number pi. And this must be equivalent to 90 degrees, so a quarter rotation. So a quarter of a circle, that angle that subtends the quarter of a circle is 90 degrees. Or we can say the ratio of that arc divided by the radius must give me pi over 2. So we can actually convert between this and that. We will call these things radians. So it's just another way to denote an angle. I mean, what is an angle in its purest sense? An angle is, I've got some sort of arc length that is subtended by 2 straight lines, and we've defined that as an angle. Here I've got a more perhaps physical relationship between an arc length and a radius. It must give me a certain ratio. So if that arc length is a full circle, this ratio must be 2 pi. If that arc length is a half circle, that must be pi. If it's a quarter circle, that must be pi over 2. So we can either use degrees or radians to describe angles. And physically, it makes more sense to use radians because we can directly relate distance in some sort of meters to a certain amount of radians. We cannot do that for degrees. or we cannot do that easily for degrees. So we are going to use a system called radians, and there's an easy way to convert between radians and degrees. We know that 360 degrees is equivalent to 2 pi radians. So we can say 1 degree must therefore be equals to 2 pi, or equivalent to 2 pi divided by 360 radians. So if you know an angle in degrees, you can convert it to radians by just taking 2 pi divided by 360. That gives you the radian equivalent of 1 degree. If you then multiply that by the right number, you can get the total number of degrees. So it's really not that it's a new concept for you, but it's really not that different from the idea of degrees at all. It's all about an angle has to be somehow proportional to the length of arc that it subtends. And we can get a much more realistic or physical relationship if we look at the relation between circumference and radius at 2 pi than just simply arbitrarily dividing a circle into 360 bits and calling each little bit 1 degree. So we're going to use radians from now on, unless specified otherwise. So we're going to denote angular position in radians, not in terms of degrees. But if you're uncertain how to move between the two, you can use this formula. Alternatively, if you know the amount of radians, 1 radian is equals to 360 divided by 2 pi degrees. So you can convert between two systems at will, but we are going to use radians because we can get physical quantities like arc lengths and so on out of it.